Well, good morning, good afternoon, and good evening, everybody. This is Phil Roberts from the University of California, Riverside, wishing we could be together in person, but planning to share with you our project virtually. We are working under Area of Interest 1, our project's 1.1, and we are looking at development of market-driven improved cowpea varieties for West Africa using mature markers. And so I'm going to click through some of the basis of our project and share with you some progress. So our geographic focus is West Africa. We have 3 participating host countries, Burkina Faso, Ghana, and Senegal. And I'd like to introduce our team together with myself. We have Bo Lam Hun and Tim Close as co-PIs here at UC Riverside. And then our host country partners are Joseph Batiano at INRA, based in Camboense, Burkina Faso, Francis Kusi with CSIR Sari in Tamale, Ghana, and Musa Dianga, our Senegal co-PI, and formerly our good friend and colleague Diarga Cisse, who are based at ISRA in Bambey, Senegal, and also with Seras at Thiès, Senegal. So that's our team. And our overall project goal is to look towards secure harvest, stabilize food supply, and improve rural incomes for the legume communities in Western Africa. And our focus is on high yielding and market preferred cowpea varieties that have good local availability, utilized by women, men, and young farmers, and also the actors along the value chain for cowpea. Just a couple of background considerations. For cowpea in the Sudano-Sahel production region of West Africa, cowpea is highly nutritious legume, vital to food security, especially for women and children. It complements dietary cereals. Unfortunately, the typical smallholder farmer yields are little more than 20% of the known yield potential. Excuse me, and insects, pathogens, parasites, drought, poor fertility soils are major contributing factors to this low yield. We're focused on using downstream breeding with SNP marker haplotypes as an approach to improve yield performance. We're not developing new marker systems. We're using existing marker knowledge and technology. And the focus here is two-pronged. One, looking at application of markers linked to target traits to add to currently available elite popular local varieties on the one hand, and then to use the technology to select among existing advanced lines and populations the best yielding and grain type varieties for release potential. We also have a capacity building effort in the area of graduate degree training in breeding and genetics, and then short-term ongoing training of the neuroscientists in molecular breeding. And I'll share a bit more about these main points in a minute. Three overall objectives to the project: applying the marker systems to add traits to elite varieties and lines, so existing varieties. Second area is field performance, to test improved lines in support of the variety release process. And then under objective 3, apply markers for quality assurance of new and current variety seed stock purity. So I'll just cover through some of the cover through some of the progress. Our project actually started, the funded part of our project started in spring of last year, 2020. So we have yet to complete a full funded year on the project, but I'll take you through some of the progress that we've made so far. First of all, we completed identifying local varieties for improvement in the host countries. And secondly, we then used the genotyping technology to verify and select for plants within the lines that have strong background purity, that are pretty much homozygous. And so underneath here for the 3 host countries, we have listed the 3 elite varieties in each of the countries. The names are maybe not so important at this point of discussion. And then the various traits that we're looking at introducing with marker-assisted back crossing. So you can see large seed, insect disease, Macrophyllina disease, and striga, the parasitic weed, resistances to those, focus in Burkina. In Ghana, again, we have aphid and striga resistance, large seed, earliness in a couple of varieties, and in Senegal, insect and disease resistance and large seed in the case of Pacao, which is a popular variety that was released from the Legume Innovation Lab efforts. So just to focus a little more then on progress in 2020 and then our plans coming up for this year and the following year in 2022. This is the area of adding traits to these targeted varieties using marker-assisted back crossing, or MABC. And so we have a stepwise plan for this. In 2020, where we kicked off the effort, crosses were made to develop F1 progenies at UCR, so we've completed that. Then crosses were made to develop the first back cross generation, so F1 crossed with recurrent parent. This was done in the host countries, or attempted in the summer of 2020. This effort was completed in Ghana, not yet completed in Burkina and Senegal due to issues of rain events and heat in Senegal, which suppressed reproductive development of plants. So we're looking at then having first back cross generation moving to 2021 this year. We will complete the back cross 1 generation development, and then all the BC ones will be genotyped at UCR. And this process I've highlighted in the next bullet point here, where we use the genotyping information to make background and foreground selection decisions to select best plants for them to then be used to cross back into the recurrent parent. And so this will then produce the second back cross generation. These second back cross generation will be grown out in the summer of 2021. And then the cycle continues. We genotype, use the data to select the best plants, and make the third back cross generation. Our host country partners will be making the back cross generations here at UCR, we will focus on the genotyping and selection process. We'll grow out backcross 3 generation plants in the fall of 2021, and then genotype and select. And then here at the end of 2021, I've highlighted again in bold, this is where we would then, with the backcross 3, we will start to intercross plants within that generation to stack the QTLs or traits to form combined or C1 backcross 3 generation indicated here. So this is an effort where we then put together the large seed QTLs with the insect and macrophemina and striga resistance QTLs. So we end up with elite lines with combination. So in the out year 2022 here, we'll be then taking those combined backcross generation, genotyping, selecting, harvesting, so taking it to the F2. And this F2 advanced generation then will be used to select plants where all the QTLs are fixed, and we can then take those forward for final development and release. So here's a couple of views of this in MABC in progress. Here's backcross 1 generation materials in a UC Riverside greenhouse this last year, materials from Ghana, ready for leaf collection for marker genotyping. And just another view of MABC in action. This is actually from material in summer 2014, where we've used MABC to develop aphid-resistant California blackeye, a new blackeye. So in photo A here, there's a high density of these backcross plants grown. They're then genotyped, and most are kicked out or removed, and the few that are the selected plants remain that then we can take to the next generation. And I just digress for a moment here. One of the really positive outcomes of our previous Legume Innovation Lab efforts, which we have now finished off in 2020, is that we have prepared for release of a new aphid-resistant blackeye variety, CB27, for growing in California for the US production market. It has 2 aphid resistance QTLs from an African line and has beautiful seed here. Bottom right, you can see brighter, whiter seed than the current main variety grown. So here's an outcome of USAID investment along with California bean industry investment. So here we are, progress. One area where a second objective, 2.2, we're evaluating Mars, Magic, and Super Magic population lines in host country fields. And we started this in June 2020. Here are shots in Ghana, Burkina, and Senegal, where we're trying to select the best lines together with marker technology information for some of these to be potentially released. So this is capitalizing on previous investment. I just wanted to touch on the fact that in terms of training activities, we're focused on student and staff training using the MatureMarker system technology is a training tool for molecular breeding, both for graduate students, and we have 3 started in the program, 2 in Ghana, 1 in Burkina, and also for training the NARS scientists. So we're working on that. Our training for women farmers based on field days and farmer participatory variety selection activities got a little bit messed up because of the pandemic, but this is an area that we'll push on and can talk more about. I just wanted to finish up with a cross-cutting theme project that we've started, which is based on cowpea nutrition. And here we're looking at nutrient status of these breeding materials that I've shared with you, with a view to using the nutrient status information to make informed decisions about release. So we will use the nutrient knowledge that's being developed. Lines have already been grown in 2020. And have those feed into sensory evaluation, panel taste testing, and cooking time tests in each host country, and follow that up with an educational program. So we're just getting started on this. Grain samples have been produced in 2020 to get this project underway, and the nutrient assays will be conducted this spring. And here just a shot that shows within a multi-parent cowpea population for protein, calcium, iron, zinc, sugar content. We have tremendous variation in these nutrients within cowpea and within some of our population material. So a great opportunity to select for in enhancing nutrient status. So we're looking at main outputs from the project in 2 areas, both the technologies in terms of varieties released and integrated into seed systems, and then our capacity building. So with that, I'll finish. Thanks so much for your time.